Using AI tools for image analysis in dermatology clinical reasoning. Dermatology is highly visual, relying on clinical and dermoscopic images. The challenge is no longer capturing images, but interpreting them accurately, especially for skin cancer. AI helps to manage the growing volume and complexity of visual data. Today's focus will be how AI analyzes images and its impact on real clinical value. AI in dermatology uses pattern recognition across many skin conditions, not just cancer. It analyzes pixel data such as asymmetry, color, texture, vascular patterns, and different structures. It transforms these into features linked to disease. AI detects visual patterns, not diagnosis, so results must always be interpreted in the clinical context. AI does not recognize diagnosis like melanoma or nevus. Instead, it identifies statistical patterns linked to them. Artificial intelligence does not see lesions traditionally like a clinician. It analyzes pixel patterns and converts them into probability scores. This example shows AI highlighting features such as asymmetry, atypical structures, and multiple colors. Patent-pending digital dermoscopy AI heat maps reveal what the model focuses on, which may result in improving transparency and aiding clinical interpretation. Most dermatologic AI algorithms implement convolutional neural networks to detect local features in dermoscopic images. Contrastingly, vision transformers add global context, useful for total body imaging and lesion tracking. In the real world, both are often combined. Their reliability depends on high-quality training data. Bias, as an example, underrepresentation of darker skin, is a key limitation. External validation across populations and devices is essential. This diagram shows the AI pipeline in dermatology, starting with image acquisition, then standardization, enhancement, and finally followed by lesion segmentation. The model extracts features such as colors, borders, and texture, and then classifies lesions as benign or malignant, turning visual data into clinical decisions. AI in dermatology is mainly used for triage and decision support. It can provide malignancy risk scores or track lesions over time. For example, AI may analyze a dermoscopic image and provide a malignancy risk score or assist in monitoring lesions over time using total body mapping. But clinicians should remain in control and must interpret results in clinical context. Studies show AI assistance improves diagnostic accuracy and sensitivity across experience levels. This example illustrates how an AI tool supports clinical decision-making in dermatology. After analyzing a dermoscopic image, the AI system provides one of three outputs. A suspicious result suggests a higher risk and may prompt biopsy or specialist referral, while an unremarkable result supports routine monitoring. If the image quality is insufficient or contains artifacts, the system returns not qualified, indicating that a reassessment is needed. Importantly, AI does not replace clinical judgment, but enhances the clinician's ability to make safer, more consistent decisions. Over-reliance on AI, known as automation bias, can increase the risk of diagnostic errors. It is important to always critically assess whether the AI output aligns with the clinical context before making decisions. AI acts as a supportive tool, enhancing but not replacing clinical decision-making. AI is powerful but not equally reliable. Here you can see examples such as skin color or phototype bias, as well as performance variability across lesion types. There are hidden pitfalls using AI. AI predictions can be highly sensitive to image scale. Even when the lesion is identical, changing the magnification may produce completely different diagnosis. This indicates the model may rely on non-clinical features rather than purely on clinically relevant information. Prediction variability depends on image input. This can all lead to a change in diagnostic confidence. AI predictions can change with image scale, showing sensitivity to non-clinical features. Even when the lesion is identical, adjusting magnification can lead to different diagnosis, suggesting the model may not rely solely on clinically relevant features. Here you can see an example of AI failure in anatomically complex lesions. Using three-dimensional total body imaging, the algorithm detects nearby benign lesions, specifically a cherry hemangioma, which is the red dot, but instead it misses the obvious malignancy adjacent on the breast. The following are principles for safe AI use in dermatology. Assess independently, examining the lesion before reviewing AI output. Interpret in context. Consider AI results alongside patient history and clinical findings. Use it as support. Treat AI as an aid, not a definitive diagnosis, and question its suggestions. The key takeaway: safe AI use relies on clinical responsibility and critical thinking. The future of dermatology lies in multimodal integration, combining imaging with clinical data, genomics, and longitudinal monitoring. AI will not replace dermatologists, but will enhance their role as decision makers supervising complex data systems. Clinicians who understand and effectively use AI will be better equipped to deliver precise, personalized care. This example illustrates how AI in dermatology is becoming truly multimodal, integrating clinical images with pathology, molecular data, and even sensor-derived information. Such integration enables deeper phenotyping and patient subtyping, supporting more precise diagnosis and more personalized treatment strategies, particularly for inflammatory skin diseases. Thank you for watching.